Hi everyone, and welcome to Mr. Carlson's lab. Today we're going to finish off the CR-88 radio receiver restoration project, and we're going to see how well it performs once it has a complete alignment. Should be a lot of fun. Let's get started. All the screws and nuts have been removed off of the face of the unit here, so I have the dowel plastic out. The two little decorative strips that go here and here have been removed. Very easy. It's just a matter of removing screws and nuts is really just disassembly procedure. These are the little markers that mark where the dial is. So on the dowel plastic, so this thing here that's cracked, when that's sitting on here like so, this little thing just sits on here like this and marks it. So nice way of doing that, so you don't have to have a line down the center. Makes this very easily replaceable. Same with the center one here. Now the meter itself did have one small sticky area, I remember right about center meter, so I'll cycle the meter and see if that removes the stickiness. If not, I'll take the meter apart. It's very simple to get apart, just 3 screws here, and the meter just comes out and I can free up the movement very easily. Usually that's done by just giving the center part just about, maybe less than a quarter of a turn. Just a touch, just to loosen it up just a little bit, and then usually they're absolutely fine after that. There really is no magic to fixing these meters. They work or they don't usually. So if a winding's open, things get a little bit more difficult, but that's not the case with this, thankfully. So now what I'm going to do is just clean the face of the unit up itself. So I'll use some cleaner on this, and then I'm going to go get some color matched paint before I start reassembling everything here, and this will get replaced on the radio, and I'll also start cleaning the chassis, and I'll explain how I cleaned the chassis as well. So, oh, by the way, this is 12 pounds. This right here weighs 12 pounds. So one chunk of the radio. You can make music with it. I'll take the little rubber portion of the screwdriver here, and I'll just tap the corner. Does that not echo heavy? That is solid. Anyways, I'll get on with cleaning this thing up and I'll be back. Of course, being extremely gentle. As you can see, it's just very, very lightly cutting the paint on the face, very, very lightly cutting it. Yet I'm not removing any of this because I'm being very careful. Too much pressure and you will remove this, so you got to be careful. You can apply pressure in areas where there is no writing, but if you do apply pressure in areas where there is writing, do note that you are going to take the writing off. You can really tell the difference, in the face color, I guess the paint over time from being in the sun and whatever, it's faded and all that. But this will cut the grease and cut all the dirt off of it. And then in the end, you end up with a nice clean face. This is already coming very, very clean. So yeah, it's looking very good. So that is the process. And as you can see, it's definitely taking off its share. Once you're done with the entire cleaning process and you've washed this all off with water, cleaned all of that off, and you've let it dry, you're going to start to see some white spots appear, and you're going to look at this thing here and go, oh no, what did I just do? All right. So don't be alarmed at that point. The paint is oxidizing very fast, and of course any scuffs and nicks the Vim product will stay in that. So what you do is you just take a cut polish and very gently go over the whole face, again being very careful of the lettering. Keep in mind, if you're doing any of these processes, you're doing so at your own risk, because you can very easily take this from something that looks not bad and turn it into something that looks very bad. So you have to use a little bit of common sense and just be very careful at what you're doing, right? So anyways, you put some of this on a rag and go over the whole thing, and that'll get rid of all the white spots. Dry the thing off, wash it and dry it, let it sit again. If you notice any white spots that you've missed, go over it and wipe it down, and you'll have a pretty uniform looking face in the end, of course, if the process is done correctly. After that's done, dry everything off, take a very high quality automotive wax, put that on there. This is only once, and then put it on and then buff it in, and this is as smooth as glass right now. Very, very smooth. And I still have to do another coat of it, but at any rate, it's very smooth and it evens it right out. So the face looks very even. In fact, the color difference in the faded area to the actual original paint really doesn't stand out all that much. Now here's the trick. It's very, very important to do all of these steps first before you get your color matched paint. So if you don't do that, right, when you're color matching your paint, depending on the actual machine and everything, you have to make sure that you've got the right shine to this as well. Now, usually paint, the paint stores will ask you, do you want a semi-gloss, a high gloss, flat, whatever kind of paint. So in this case, I would say this is very close to a semi-gloss, not a high gloss finish. So when I get the paint matched with this, I want an actual semi-gloss finish. And not only that, you have to make sure that it is polished, because it kind of deepens, it richens the color a little bit after you polish this. So if you don't do all of these steps first and you go get your color matched paint, it's going to stick out like a sore thumb when you're fixing all the little scratched areas here, and you don't want that. You want it just to blend in, and unless you're looking at it from an angle with crazy light shining on it, you're not going to really see any type of difference. Other than completely I would say stripping this panel off and getting this thing repainted again, and then getting the lettering put back on again, for something like this, it's about the best that you're going to get, and this is turning out very, very nice. So I'm very pleased with the results of this. It's a world of difference from what it was. I've taken off years and years of grime off of this, and the face is actually looking very, very nice. I don't know if you can see that in the camera. I hope you can. The lens is fixed on this, but you can see it's very, very shiny, and this is only one coat of wax. So I'm going to put the second coat on now. I'll go get the color matched paint, get all of that underway, and get the face back on the unit, and I'll explain about cleaning the rest of the radio, which is pretty much the same process.
The chassis cleaned up the same way the face did, so I used the same formula in order to get all of the grease and dirt off the chassis, and it works very well. I also use it on the capacitor block here. It looks like brand new. There are some nicks and scratches on the actual transformer from somebody in the past, so I'm not too worried about that. As you can see, it cleaned all the rust off of these as well, so it doesn't even show any rust on here at all. So very easy to do. The reason that I use both Vim and WD-40 together is that the WD-40 is very good at releasing oil and dirt and things like nicotine stains and all of that from the past, right? That releases all of that from the chassis. And then of course the Vim itself works as, I guess you could say, a little bit of a scrubbing agent to get the rest of the dirt off. So the two together work very, very well for a lot of things. So anyways, that's what I've done in here, and as you can see, the chassis itself is, it came out very well. So just a whole lot of time really in cleaning this. Toothbrush and lots of Q-tips. I use the long ones and the short ones, and a lot of the times what I do is I take the actual cotton on the end and I'll pull it loose just a little bit. So by pulling it loose, you give yourself just a little bit of a tip on there, and then you can get down into the small areas where the screws are like this. And again, just a whole lot of time, so you can see, and it turned out very, very nice. So that's about the best that it's going to get. I would say, there is some pitting in the chassis itself, some mild pitting in the back by the rectifiers and stuff like that. But all in all, it's, I don't know, I would say it looks about an 8 out of 10 maybe, almost brand new. So anyways, there it is. So now I just have to get the face back on this, and we'll get right into the alignment and take a listen to it and see how well this thing performs. Oh, and the assembly date of this radio receiver is stamped on the front of the gearbox with some red ink. It says January the 19th, 1945. So it's the actual day this radio receiver was put together. The receiver restoration is coming along quite nicely. It's been about a week and a half since the last video clip, and a lot of things have happened within that week and a half. What I'm going to do is just share the highlights with you today. Again, by the end of this video, we're going to get to see this thing operate, and we'll see how well it performs. One of the things that I would like to talk about just before I go about putting this capacitor shield on is cleaning the contacts on that, because I notice in a lot of the restorations of these radio receivers, at least the ones that I've seen, nobody seems to do this. So it's very, very important for the shielding of this unit and to make this section work correctly. The grounding has to be good. And the grounding is very, very specific because we're not dealing with DC ground here, we're dealing with AC grounds, and they are a little bit tricky. RCA spent a lot of time working that out in this radio receiver. So just to give you an idea how tricky it is, you'll see the box itself. If we look at the capacitor box, which is this entire box unit right here, you'll see it's stood off the chassis here. You see that little gap under there? You see how there's a gap all the way along? You see between the IF transformers, you see the gap. So it's not actually screwed down to the chassis at all. It's actually stood off the chassis, but it's grounded in very specific areas underneath by some spring-loaded tabs. And those spring-loaded tabs look just like this. All right, so they're spring-loaded, and when they tighten the box down, it presses down on these and makes contact to this box right here. Now, again, it has to be grounded in specific areas in order to make this oscillator and this entire assembly work correctly. So if you look right here, you'll see in the back that there's a screw right there with a rubber grommet. Well, it can't be grounded there. It has to be isolated at that point, and that's the reason that they've done that. Yet, it's perfectly fine to ground it directly under this portion right here. And you'll see they've soldered the capacitor itself to the main tuning box, right? Now, it's okay for this one to be soldered to this side, but it's not okay for this one to be soldered to this side. This one has to be connected to the opposite side of the box. So if we look here, let's move this around, give me a moment here. If you look at the opposite side of the box right here, let's move the focus down. You can see we have a braid from this one here, and if that's not strange enough, it's also grounded to the shielding inside. You can see here, see how this runs down through holes in the chassis? It's also grounded in those boxes on the underside as well. So it's grounded in very specific areas, and it needs to be grounded like that in order for this thing to work correctly. So, knowing all of that, we have a box that fits on the top of this to shield this, to keep everything shielded correctly. All right, so let's move the focus here. And this box has to be cleaned up very well, and all of the spring-loaded tabs on this have to be cleaned as well. Now, in order to clean these, you have to drill out the brass rivets and mount some screws on this, on the bottom side here with the nuts on the top. The nuts have to be on the top due to clearance issues, or they will hit the actual capacitor itself. So this all has to be done. So I took these all off and put them in Tarnex, cleaned them off in Tarnex, and then cleaned them again with a little bit of Vim, and then polished this all up. And now this is ready to go back on. So these spring-loaded tabs that you see here and all the way along, what they do, this goes on like so, is they press on these portions of the capacitor. And that's crucial for correct grounding and for the operation of this radio receiver. I see so many people not cleaning this, and these have bad connections on them, so you don't get the correct performance out of the radio receiver. Very, very important. Again, you can't look at this through DC eyes. You have to look at this through AC eyes. We're not dealing with a DC grounding system. We're dealing with an AC grounding system, so we're dealing with RF. So now, if I put this on here, just like so, I also pinch the box a little bit to make sure that it's nice and tight. All right, so slide this forward just a touch, right about there. All right. Now you can see, if you look at the screw hole down here, just barely see it. See a little screw hole right down there? You see when I press it, see how it comes in, see how that it, right about there? So I have to press this down to put the screw in, which doesn't make the reinstallation of this box very easy, but I have to press this down. The reason that it keeps popping up is the spring tension of all those tabs underneath pressing on that capacitor. So just keep that in mind. If you're going to restore one of these radio receivers, you have to do that. So you have to take all of this apart and clean those out. And of course, getting under those brass rivets is impossible. You have to take them off. So a little bit of work is required there. So now what I'll do is I will push this down and put some screws in there. And in the front here, you can see there's also screwed at the front here. So lots of tension there, lots of spring tension to make sure the grounding is just perfect. All right, here's the big reveal for the new AR-88 black dial plastic. So this is how it would normally look. This is the CR-88 color scheme with this kind of a gray front panel here. Of course, minus the RCA symbol. All right, so this is how it looks with an AR-88 black dial plastic. Doesn't that look fantastic? I don't even know what RCA was thinking using this. That looks so much better. They should have just stuck with the black panel for the AR-88 and the CR-88. It works so well with all the black knobs and it contrasts the gray front panel. Even works well with these polished strips here. So I've worked on a lot of CR-88s in my time, you know, of course with this color scheme. And I honestly have to say now, this is the best looking one that I've seen. It works so well with that front panel. And of course, when this goes back into the black case, it will look even better. So I've taken all of the bakelite knobs and cleaned them up. So I've cleaned all the bakelite here with just a polish, and I've repainted the lines on them as well. So originally the lines were yellowing, probably from stuff from people's hands getting on them and stuff. So they're a nice crisp white color now. And that really helped the appearance as well. And all of that touch-up paint is all over this front panel. So it was kind of I guess you could say an interesting match because the front panel hasn't faded evenly. There are areas that have faded differently. Maybe it was in the sun. Portions of it were in the sun. So I went for the center of all of the gray, and I think it turned out pretty good. So if you look, I've got the light shining on it in a way where you can see the actual color match a little easier. So I would honestly have to say I don't think I could get any closer with the color, with just one color to match the entire panel. So it worked out that incredibly well. So all in all, I'm extremely happy with the appearance of this receiver. So hopefully the performance of the receiver will match the way it looks. So let's get on with this restoration and find out. Before the alignment is done, all the shielding needs to be put back into place. And as you can see, it is all back in place and it's very well cleaned up. There's all brand new hardware on both of these boxes, and the electrical connection should be very, very good. This is cleaned up very nice, and all of the mating surfaces are nice and clean. So now that these two boxes are put back together and all the screws are torqued properly, the screws and the nuts, we are ready to get into the alignment. These are the preliminary adjustments for the CR-88 radio receiver before alignment. So the tone can be anywhere. The antenna adjust has to be half meshed. All right, so if you go behind this knob, there's a long shaft, which you'll see in the other shot here, that connects to this capacitor here where my finger is. Those plates have to be half meshed. So fully meshed means that the plates are fully in one another, and then fully open, all right, means that they're completely separated, so you see two halves, you almost see a full circle. So what they have to be half meshed, which looks like this right here. All right. Now, if you have put your radio back together or somebody else has worked on it and they're not half meshed when this is pointing to 12 o'clock, you need to basically half mesh it wherever the knob sits. All right. So say it half meshes right here. Okay. Stick an Allen wrench into the backside of the knob. Loosen the knob up, turn the knob until it is at 12 o'clock, and then tighten it back up again so that the capacitors are half meshed in the back. If for some reason you're having a hard time getting them right at half, it's very easy. You can fully mesh them. It's very easy to see them fully meshed because the plates, they sit even with each other. And then adjust the knob for 9 o'clock if you want to do that as well. Okay, so right about there is fully meshed. All right, and then this way this is fully open. And then we have 50%. The same goes for the beat frequency oscillator. It has to be half meshed as well. I talked about the crystal phasing control and the IF alignment, so I don't really need to go over that again. But again, you can see it's pointed at 12 o'clock for the adjustment right here. All right. So that's how this starts off. Now, the very first thing that we're going to do in this alignment is the beat frequency oscillator before I adjust the wave trap, because if I adjust the wave trap, I'll null out 455 unless I really cram it in from the signal generator. All right, so in order to adjust the beat frequency oscillator, I need to feed the antenna jack in the back side with 455 kCs. You can see this on my signal generator back here. I'll move the focus. There's going to be a lot of movement here because there's so many things to do, and you know, getting more work than 2 cameras in here is just getting ridiculous. All right, so you see that in the back there, 455. And I've got 0.1 millivolts right here. All right, so what I'll do is I will turn this on. All right, so now I'm feeding that into the antenna jack on the back side of the radio receiver. Now, what I'm going to do is put this from receive mod to receive CW. Okay, so I'll put that here, and I'll turn the volume up. And you can hear that I have a tone in here. So this needs to sit right at 12 o'clock, and I need to adjust that for 0 beat. Okay, so what I'm going to do is I have a tuning tool inside the wave trap on the back side already, because that's hard for me to move around. So what I'm going to do is grab another tool here and do that. So, you know, as I say, there's going to be a lot of movement here. I'll walk in front of the camera for a moment and find one that will fit in the top of this here, and that should be okay. Okay, so now you'll see on this camera, this is the beat frequency oscillator transformer right here. So this needs to be set right at 12 o'clock or half meshed. So what I'm going to do is just move around, make sure that is at 12 o'clock, and that's very close to 12 o'clock. Now I'm going to listen for, you can see the where I'm going to put this in here. Maybe this end here might be a little bit better. You can see how just touching the cord moves the frequency. Right about there. So you can almost count the cycles. Now if I just breathe on this, so you can hear this. So that's 1, 2. So you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You can see how close that is, okay? So that's cycles away when I'm listening to, so I can do this. And that's where we want it. So right now we're at 0 beat basically, all right? And then we're off 0 beat, so we can go each side. So the beat frequency oscillator is now adjusted. The radio receiver needs to be back into its actual case for its final alignment, and it needs to be fully warmed up. So it'll be in the case, and I'll let it run for about an hour or something like that, maybe even 2 hours to get a really good alignment. Make sure everything is to temperature. So this is just a preliminary alignment. Once this goes back in, I will give it what you would call as a touch-up alignment once everything is hot. So the radio receiver right now has been on for about 2 hours, but it's out in open air and there's no shielding in here. As you know, that the outer box that fits over this entire oscillator section is removed. So that traps the heat from the tubes a little bit, and it'll create a little bit more heat in there. Again, these things are very sensitive to temperature change, so it needs to get up to temperature. A lot of people think, you know, oh, there's lots of tubes in here, why don't you fan cool it? That's the absolute worst thing you can do for a radio receiver like this, is run a fan inside of it. Just the temperature variation, it makes these things incredibly unstable. All right, so they have to get hot. These are designed to run hot. That's the way they are. And you know, if this is in a nice warm room and you turn this thing on and let it sit for an hour. Once it's warmed up, it will be almost, I would say, rock stable. They're very, very stable, especially when they're rebuilt. All right. And again, it all depends on how it has been rebuilt and how it's been put back together and all sorts of things like that. So if you follow what's been done in this radio restoration series, you'll have a rock solid radio receiver. Okay. So anyways, that there is the beat frequency oscillator adjustment. The next adjustment is the wave trap. So we're tuning a 455 signal to a minimum right now. So we want to bring that to the lowest point in the receiver. So we're trying to null 455 at the input of the radio receiver is what we're doing. So we basically don't want the radio receiver to hear IF. So that's why they gave this thing a wave trap. So with the signal generator still set to the exact same settings here, I'll just bump the focus here. So with it still set to the same settings that we were using for the beat frequency oscillator, what we're going to do is use the BFO now to our advantage because we've just adjusted that, and we're going to use that to listen to this. So what I'm going to do is leave everything the same here. I'll turn the volume up. Boy, that's hardly moved. Listen, that's cycles. For being open in air like that, this is fantastic stability already. So what I'm going to do is just give this a comfortable tone. Okay, so that's a comfortable tone there that we can hear. Now what I'm going to do is tune this tool for a minimum. I want to bring that right down into the dip. So just the lowest amount that we can get. If for some reason you need more signal, you can add more amplitude, or if it's too high on your radio receiver, you can bring it down as well. All right, so you just want enough so that you can hear it and then tune that until you hear a dip. Okay, so I'll move here. I'll grab that tuning tool and I'll give it a twist. You can see I've passed it. I'm coming up on the other side now. And that's about minimum right there. And that's it. That's all there is to it. So now the wave trap is adjusted, and that was far off. So that wave trap is very important. Now this needs to be adjusted before any of the broadcast band alignment is done, because this will affect that antenna alignment. So this is very, very important to do this first. So don't try and do any of the RF alignment in the front end without first adjusting the wave trap. That has to be done, number one, right after the BFO anyways. Now that we've adjusted the beat frequency oscillator and the wave trap, now we are into the actual major alignment of this radio receiver, which is the oscillator, RF, and antenna section. And we'll start with the broadcast band first. So everything that you see on the radio remains the same as before, except this knob here. You move it to receive mod, and you can adjust the volume to whatever's comfortable at this point. So what we need to do is adjust the dial tracking on the AM broadcast band. So we have an oscillator in here, which is a completely separate unit than this actual dial. They're not linked in any way, so we need to make them work together. So the oscillator has to be at the same frequency that's displayed on this wonderful piece of artwork that, you know, RCA created way back when. That's basically what they did, is they designed the oscillator when they first put these radios together, and they have a huge piece of paper and they write everything in by hand. So everything that you see on here and all the spacing is just a lot of research and a lot of time. Again, two completely separate items that have to align with each other. All right, so what we're going to do is align this at the bottom end of the broadcast band, which is 535 kilohertz, which you see, which is on the signal generator back here. I'll move the focus up there so you can see that. So the signal generator needs to be set at 535 kilohertz. The RF output level is about 100 microvolts. It's not specific. Don't worry about it. Just don't overload the front end of the receiver. 30% modulation is the tone. So I have a 400 cycle tone in here. It's not specific. So it can be 50% mod, it can be 20% mod, not a big deal. You can have 1,000 cycle tone, 400 cycle tone, 600, whatever's pleasing to your ear. The only thing that's really specific is this at this point. Okay, don't get too hung up on the RF output level, just whatever you can hear through the radio receiver and, you know, something that you can peak on the meter. All right. So a lot of people also get hung up on the RMA dummy thing, you know, for the, I'll just focus this on the paper here. They get hung up on the RMA dummy thing here, like, you know, in this case, they want you to use a 200 picofarad dummy antenna, or a, you know, a 200 ohm dummy antenna that's listed under their dummy antenna section here. Don't worry about that. You can connect your signal generator directly to the input of the radio receiver. In the end, what you're going to do is peak up the antenna section of the radio to your antenna. That's how you get the best performance out of these radio receivers. If you're working on this radio receiver for somebody else and you don't have access to their antenna, then you can use an RMA dummy. All right, so you don't have to get too incredibly hung up on this. If you want to follow this directly, that's absolutely fine as well. You can use a 200 picofarad capacitor and later on a 200 ohm resistor. All right. So for my purposes, I have the 369 antenna. I'll move the focus down here again. I have the 369 antenna, so I will just end up peaking up the antenna section to that. That's the only thing that has to be re-peaked. Once you peak up the RF section and everything else like that, it's absolutely fine. All right, so I'll get to that when we get to that portion of the alignment. All right, so I don't want to make things too confusing. It's a very easy alignment. All right, so what we need to do is adjust these two here, L51 and C16. All right, so in the top portion of the radio receiver, this is L51 right here. All right, right here, and this is C16, this plunger style capacitor. I'll be using these two tools. This is the one that came with the RCA CR-88, and this here is nothing specific. You can just use an insulated, you know, blade type screwdriver that fits inside this, you know, this little brass end here. Not a big deal. As I say, you know what? You can almost use a rock and a hammer to tune these things. You don't have to worry about it. A standard nut driver will loosen the nut. You don't actually need this tool. You just need a deep socket, and you can use a plier to pull the plunger capacitor up and down. I just have the actual tool that does it. That's all. All right. So I'll loosen up the nut on C16 here. So loosen that up. So just loosen it off like so, and I will adjust L51 at 535 kilohertz. So I'll turn this up, turn on the signal generator, which it is right now. So I hear nothing on the radio receiver, so I will pop this into L51 here. Again, flat blade screwdriver, you know, not a big deal. You can use whatever you need. So we'll see if we can find it. Right at the bottom end, everything's good. I think we're good. All right. Well, there it is. So now we can use this meter here as an aid to peak everything up. Okay, so see the meter right here? Right about there. Okay, so that's peaked up at 535. So now we've just done the lower end of the alignment here. So now what I need to do is go up to the extreme upper end. All right, so you can see on the actual alignment paper here, they're nice enough to say that, extreme. So you can see extreme low end, that's where we are right now at 535. Now we need to go to the extreme high end, which is 1600, and we need to adjust C16, all right, which is that plunger style capacitor. Okay, so I'll move this up here. This is just a logging dial, so don't get too hung up on what that says. All right, this is what's important right here. Okay, so right at the extreme top end here, that's it. That's as far as it goes. All right, so we'll leave that right there. Again, don't get too hung up. That doesn't need to say 0 or anything like that. It's just a logging scale. So now we go back over to the signal generator here. I'll move that. All right, and we need to go to 1600. So we go to 1.6 megahertz, or you can enter it as 1600 kilohertz. It doesn't really matter. Move the focus back down here again, and we'll zoom on in to this. And now I will stick the plunger style tool in, so this little hook hooks into the top of the tuning capacitor here, and I need to move that around. All right, so it just hooks into the top. Now I'll push this up and down. You might be able to see a little bit of this here and in the other shot. So I'll move this down. I'm not hearing anything. Got enough volume here. There it is. Okay. So turn that up quite a ways. Obviously the capacitors definitely need adjustment here, so we'll zoom in. We'll use the meter again as an aid, even though it's very low. Right there. And that's the top end. Okay, and that's pretty much the alignment right there. Now sometimes you have to go back and forth between the band ends if it's really, really out of alignment, but we'll find out. Let's go back to 535. Okay, so I'll just tap the focus here. So I'll go on the signal generator over here again. I'll just enter 535. So 535 kilohertz. Okay, so we're back at 535 again, right? You can take a look at that. All right, back at 535 over there. All right, and let's go down to the bottom end of the dial, the extreme low end, and let's see how well that is, how well it's tracking. Looks pretty good. Zoom on in here again. So I could use a bit of a touch-up. You can see it's a little higher over there. Now that might actually be because the RF hasn't been done yet, so it might, the capacitors in the tuning section here haven't been tuned. It's just this particular portion here, so I'll see if we can get anything better. If not, we're right there. No, we're right on top of it. So that's just RF and antenna section alignment that's going to fix that up. We could also use this. You got to remember that we're not moving this control here at all, so we can also use this to peak. We want to do all the adjustments with this, again, a half mesh. So if I move this, you can see we gain quite a bit of signal over here. But again, not until the end. We won't worry about that till there, to that point, okay? All right, so that's it. That's it for this alignment. So let's test the dial tracking. Let's, so what do you think we should try this at? Let's try it at, say, 1 megahertz. So I'll move the signal generator here. You'll see me move the signal generator over here. All right. So I'll move the signal generator to 1000 AM or 1 megahertz to make things quicker. All right. So we'll come back to here again. And we'll zoom on in. Now keep in mind that the camera's off on an angle a bit, so it'll probably, like, you see how that doesn't look like it's lining right up with the lines there. If your needle's width either side, you're doing good with any of these receivers, so let's find out where we are. Okay, so I'll turn the volume up. So now we should be about 1,000 here. All right, so 900, we're coming up on 1,000. Couldn't ask for anything better. It's right there. So the dial tracking is spot on this radio. No problems whatsoever. We're now going to adjust the antenna, RF1 and RF2 in this radio receiver. So in order to do that, we need to be at 1500 kilohertz, and we also need the signal generator to be set to 1500, which you see in the background over here. So it's set at 1500. Everything is the same, just move the frequency to 1500. All right. Now, we need to locate on the paper here, we'll zoom into our alignment sheet again, C37 and C59. All right, so C37 and C59 are right here and right here. So these two plunger style capacitors right here need to get adjusted. And we're just looking for a peak again. All right, so we'll keep an eye on the meter here, touch up the focus here. And let's see, I'll give it some volume. So you can see the dial tracking is really good. Now, that's right at 1500 to my eyes because the camera's moved over this way, right? So it's doing really good. So I'll loosen up the nuts on these two adjustments here. Just like so and like so. And I'll start with the first RF first. Either or is fine, really. Just going to be bringing them to a peak. Okay, so I'll pull this plunger up or down right now. So I'm pulling it up.
Whoa, that one's way off. Now we can also adjust this here for a peak at this point. You can see on the instructions, it says here, maximum output. So position of antenna trimmer. So we can move this. And then move this. Turn the volume down just a touch. Not bad. Okay, and then I'll move over to the next plunger style capacitor. It should be RF2. It was a little sticky, that one. This one here is a little bit tougher to move. And that one was pretty much spot on right from the get-go. So those two adjustments are done. So now what we need to do, put this down here, is we need to move on to L2, L14, and L24. So I'll need to fit a tool into the backside of the chassis for L2. So I'll get that done and we'll adjust that. All right, I have the alignment tool in the back of the radio, which you can see right here. So that is on the sheets here. That is fit right into this little area right here. So I'll zoom in on this. So that's fit right into here, into L2. All right, and that's 600 kcs. You see the dial is at 600, and the signal generator, again, is now tuned to 600 back there as well. So I'll focus in on that for a moment. There you go, nothing's changed. 600 kilocycles right there. All right, so now if we look at the instructions here again, we'll zoom in on this. Zoom in on this piece of paper before I go grabbing the other one. All right, so if we look at the instructions here again, we can see that we need to be at 600 kilohertz, which we are set at now, and we leave the position of the antenna trimmer untouched. All right, so it needs to sit in the same spot where it's peaked up. So the antenna trimmer here is still pointing there, so untouched. All right, we don't want to move that because that's the alignment point. And now we're going to adjust L2, L14, and L24. So L2 is right at the back of the radio, so I will adjust that first, and we'll keep an eye on the meter here. Okay, so we'll give it some volume. Dial tracking on this is great. Okay, so I'll adjust L2, which is in the back. Whoa, this is way off. That's about the peak right there. And now we need to adjust L14 and L24, which are right here and right here. Okay, so I will use this tool again, and we'll adjust L14 for a peak here, and that peak is, wow, that was way off. That was way, way, way off. Okay, so let's go to L24 now. Lots of traffic outside here today. You can probably hear that in the mic. Yeah, that one's way off as well. Wow, look at that, how far off that one was. So that's going to really increase the sensitivity of this radio receiver here. So I'll turn that down just a touch. There, and I'll go back to L14 here. And I'll give L2 a quick twist on the back again one more time. Now L2 will have to be adjusted to my antenna anyway, so I'm not really too concerned about that, but we're just trying to get the peak out of it for right now, and it's looking really good. So now I can adjust the antenna trimmer because this is all done. And as you can see, it sits pretty much in the same spot. So not bad. Not bad. A lot more sensitivity out of that. So the sensitivity of this radio receiver is improving incredibly. So now that all of this is done,
I have to do the exact same process to all the other bands in this radio receiver. So basically it's just rinse and repeat everything that you've seen here from the oscillator and of course the antenna and first and second RF. So I'll get all of that done and we'll take a listen to the radio receiver and see how well it receives. Again, I would share all of those processes with you, but it's just the exact same thing. I'm just moving different plunger style capacitors and moving the different coils around. Exact same process. The radio receiver is now completely aligned and we can listen around the bands and see how well it performs. We'll see how sensitive it is. For those of you that want to see how incredibly sensitive it is with a piece of test equipment attached to it, I can do that as well. I often, get the comments, it's an old radio receiver, the new modern equipment, would easily outperform something like this. Well, there's a reason that they use these things at secret listening posts, and you're going to see that here in just a moment. If you are familiar with aligning radios or know anything about the sensitivity of radio receivers, what you're about to see will probably shock you. So, at any rate, this is off frequency right now. It's not on an actual radio station, so it's not at, we'll say, 1 megahertz. So I have the signal generator set to 989. And you're probably asking yourself, why do you have it set to such an odd frequency? Well, I have a shielded piece of cable running from the back side of this radio receiver to the signal generator over here. It's completely shielded right to the signal generator. The only exposed pieces, really the exposed piece, is one little alligator clip this big. All right, and that goes to the center conductor, to the signal lead that goes into the signal generator. With just that little piece of clip exposed, this is trying to receive a radio station as well as listen to my signal generator at 1 megahertz. So I get a heterodyne happening. I get that sort of a whooshing noise because they're, very close in frequency, a few cycles out or something like that. You kind of get a shh, 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 shh noise like what we got when we were listening to the BFO. That's how incredibly sensitive this thing is. With just a little clip lead, it's trying to hear a radio station at 1 megahertz. So I have to go off frequency so I don't get that effect. So the signal generator is set to 989, and so is the receiver right now. If we look at the signal generator here, you'll see that I have 1 microvolt worth of signal going into this radio receiver right now. All right. So what we'll do is take a look at the radio receiver here. I'll turn up volume. That's 1 microvolt. Okay, so easy copy at 1 microvolt. You can basically ignore the meter because these meters are always a little bit picky, and it really is nice. Like if you're listening to an AM radio station, you don't get the thing pinning out all the time. It will register very strong radio stations, and up closer to the 3/4 the way up, I would say, on the meter. But you really don't get that pinning effect all the time. It's a really nice balance with these things, but sometimes they are just a little bit stingy. So I'm not worried about that at all. So don't pay no attention to the meter at all. We're going to actually just listen to what the radio does itself, okay? If you look very closely, it is registering. All right, this is 1 microvolt, okay? So what I'm going to do now is we'll focus back onto the signal generator here. I'm going to go below 1 microvolt. Okay, now you're thinking, oh, it's kind of disappearing. Still there. If this was a CW copy, there would be no problems. Here, I'll turn it on and off. All right, so here we go. Off. On. Okay, off again. I'll turn it on. Okay, so now let's go below here. And get the right digit going. Still there. Still there. Getting pretty faint. And at about 0.05, I'd say that'd be a pretty tough copy if you were listening to CW. See if we can It's still there. I don't know if you can hear that. It's still there. So it's on, off. You can see these blinking lights. When the blinking lights are on, the signal generator is not putting out any signal. All right, so it's on. So we'll go back up. Very easy copy at 0.1 of a microvolt. Again, off. So there's the reason that these radio receivers are used at listening posts. That is very, very sensitive. Here's an example of this listening at 1 megahertz and 3 cycles off. Hear it pulsing? That's because it's heterodyning with a radio station. So I'll turn this off, and I'll turn it back on. So you can hear about half a cycle. So that's what I was talking about. And that's with 0.1 of a microvolt signal running into the radio receiver. This is trying to hear them both at the same time. That's why we're getting that effect. Again, incredibly sensitive. Let's take a listen to the broadcast band. So I have this in the broad position and I have it on AVC so it doesn't overload. So if you don't have this on AVC and you have it in manual, you have to basically ride the RF gain control or it will overload. Now this is actually pretty good. It takes a lot of signal to overload this radio receiver. It's so well designed, but just nicer to have it in AVC. This is one extra thing I don't have to worry about. All right, so in fact, I'll add a filter to the camera so that way the meters don't wash out so much here. And yeah, let's take a listen. All right, here we go. Look at that, just hardly any volume. That's loud. Take this up. All right.
There's no way in the world that God could be in this, and you know absolutely the truth, but I don't know it.
It's specialized coverages for heavy trucks. He had 31 first half points. He just ran out of gas in the second half. He had nothing left in the tank. It was obvious. He had no lift on shot.
You can hear the fidelity difference from broad to position number 2. It's narrowing things up.
To put his team on his back in the fourth quarter, in the second half of these closeout games, that
allows our ego through their overnight work in Surrey.
blame him.
No, if the media to make so
The people of it.
Like you're going to eat on it. The trick is to not lose money on this per diem, and that would be so your budget is no more than your per diem.
okay.
That's your budget.
So I mean,
Yeah, if you can eat for free.
As great as he was in these playoffs, was nowhere to be found in that second half. And again, I mentioned D'Angelo Russell somehow managed just 2 points and didn't even log 5 minutes on the floor. And so LeBron James understands that he has a body that literally sees. When I go out,
After being down 3-0 in the series, it came thanks to a tip-in at the buzzer by...
You want a stone to be your ally in that.
idea.
Point your intention. You can listen for your inner guidance. And if you want a stone to be your ally in that, look and you'll find
The tempo. Completely putting the Lakers front office, Rob Pelinka, on notice, saying we need to do better as a roster. Because if you expect this from me in year 21, where I couldn't even pull this off in year 20.
So there's a very good example of the sensitivity. There are so many stations in there. You could just move this so little and just find so many stations. And of course, if I narrow this up even more, this is more for CW. From 3 to 5 was basically, I would classify that as CW listening. But there's so many stations to pick out, and here's them all. It's just listening to everything. It's an amazing receiver. I'm very, very happy with this. All right, let's listen to a shortwave band and see if we can hear anything. It's pretty late at night, so conditions really aren't working on a lot of the bands. But let's take a listen and see if we can hear anything there. Let's take a listen to band number 2. So that's 1.6 megahertz to 4.5 megahertz. So the top end of the broadcast band, through some shortwave bands, also through some amateur radio bands as well, and then we'll end up at about 4.5 megahertz. A lot of computer-generated noise and stuff in there right now. So again, it's late at night, so there's not going to be a whole lot of action here. We will hear some radio stations right here. This is the top end of the broadcast band. And we're already through that. Again, not a whole lot of action here tonight. Oh, the WWV is there. 2.5. Oh, some shortwave station here, 3.2 megahertz. Interesting. So now we're coming into the 80 meter ham radio band. And there's some CW right there. This is a good opportunity to show you how to receive CW on this. So the first thing you do, find what you want to listen to or around the area, turn the volume down. Isn't that a good way to listen to CW? Okay, so now first you put this into CW modes like so. You turn the volume right down. All right, you move this to manual. You always want to turn the volume down first because things can get very, very loud very, very quickly. So you turn the RF gain down like so. So turn it down, we'll say about 3/4 of the way. Now what you do is advance the volume. Look at that, we're receiving CW just that easy. So now, if we want to clean this up just a little bit, that's why we have the selectivity control. So what I'll do is I'll wait till I move this off to the side just a bit. Doesn't that sound nice? That's how you listen to CW. It's just that easy. You can adjust the tone by moving the BFO around. Now, another thing that you might be wondering, and I probably neglected to mention this earlier, is the S meter. Now, the S meter really only works when you're in the AVC mode with the RF gain maxed out, or so the RF gain is to the maximum. This is just normal operation for all of these receivers. As you move the RF gain around, you'll see the meter move. See that? That's normal operation. In fact, that tells me that everything's working okay. So that's how these things operate. So the S meter, or the dB meter in this case, is basically only good in AVC mode and RF gain maxed. That's where you're going to be using it. And then after that, you're relying on your ears. So most of these, well, many of these receivers had an actual, just a plate in here. They didn't even come with a meter. So this one here is had the luxury of actually having a meter in it. So that's how you receive CW, just that easy. Now, if you want to go back to just receiving standard, AM voice mode, or modulation mode if you like, the first thing you do is you turn the volume down again. All right, go back to AVC, RF gain maxed out, back to receive mod. Now this doesn't matter, it can be anywhere at this point because it's switched off, and the crystal phasing you can pretty much have anywhere as well, but I'd always point it to 12 o'clock. And move this back to broad or position 2, wherever you're happy. And then now you can advance the audio control, because you'll see here, it gets loud very, very fast. All right, so let's move on. Some foreign broadcast there. Again, the band conditions are out right now really for this whole entire area. I'm sure that person that was hammering away on the CW key there probably wasn't all that far. And that's pretty much it for band number 2. Let's take a listen to band number 3. So that's 4.5 to 12 megahertz. So right now we're at the 12 megahertz end of things because we stopped off at that end, at the end of band 2. So we'll work our way down this time. Some stations in here coming in now. That would definitely be a distant broadcast. So these stations right now are coming from across the world. This is very, very far away, probably halfway across the planet at this point. There's the WWV at 10 megahertz.
You need to pay attention to the high methane foods, which are a major driver of global warming. A big driver of
we lived. And we kept the faith. And we learned obedience.
The aforementioned Zoe. Here she is speaking to a Danish academic who spent 30 years studying the effects of music on shopping habits.
Some single sideband. See if this person's going to actually talk long enough for us to tune them in. See, this is the thing. You switch to CW mode trying to tune them in and they just go quiet. See if there's anybody else. Oh, lots of CW down here. Almost don't even need to put it into CW mode. They're, you know, transmitting on top of each other. They're making their own tones. Now we can see. Turn that down, turn this here. Maybe go to selectivity number 2. See if we can make anything out of this. So as you can see, it's really easy to receive sideband as well. So he's asking for a relay. Again, an amateur radio operator, or ham radio operator if you prefer.
I'm sorry, just not making it over here. Hang on a second, we'll try in a few minutes. Let's see what happens in the next few minutes. Start coming in very strong here, the Victor Kilo 2. I do have static crashes. There is some noise on the frequency, and the lighter stations are just going to be difficult. Do we have anybody else? Any other DX check-ins at this time, over?
There you go. So that is sideband using the CW mode. Again, very easy to do. No problems whatsoever. Okay, so back to broad. We're still in AVC mode. And I didn't even go to manual for that. I just left it in AVC mode. And yeah, we're ready to go again. Lots more CW.
Open our minds to the fact that all this ideology about giving that people have been programmed into.
And it sounded like right.
Only tropical phones are actually series call oscillator.
And I think we're at about the end of it. Well, we might get the WWV at 5 megahertz. That's there. There it is. Time signal. And now we're just going to get into computer-generated noise, same area that we were before. So there you go. That's band number 3. A lot more action on band number 3 at this time of night. Actually pretty surprising. I was expecting it to be pretty flat, just like band number 2. Band 4, 5, and 6 at this time of the evening are just quiet. There's so few radio stations in here, it's pretty much not even worth scanning through. 5 and 6 are completely just noise. And there's a little bit here, as you can hear. We're kind of at the top end of the last band. So the last band was at 12 megahertz. Right now we're around 12, just a little before. That's about it. I think there was something up at 13.8. There's something here, right? Around 13.8. So normally the WWV is at 15 megahertz as well, right? Well, you can hear there's just nothing there. So that's, the conditions are just not in right now for these bands, so there's no point in really even scanning through these higher frequencies. So for now, I think we'll cut it off there, and when it comes to the point when we have all the radio receivers here and we're comparing them all, of course, I'll be doing that at different times of the day and all of that so that we can, you know, really compare all the different bands. Again, this radio receiver is going to be definitely a challenge for the other ones. You know, it's an old, you know, CR-88 from 1945, but you can really see that RCA really put the time into this thing. And, you know, you saw the sensitivity coming from the signal generator there, and just the fact that, you know, it was, you know, heterodyning with a radio station down at, what was that, 0.1 of a microvolt or something like that, right? So incredible radio receiver, extremely happy with it. I honestly have to say, you know, if you're a shortwave listener and you have a chance to pick one of these things up restored, I would strongly suggest it. Probably one of the best, I would say, strongest radio receivers that I have actually restored over time. So I've done many of these things and I know how they operate, but I've never done one and shared the entire process with all of you. So I hope you enjoyed the CR-88 restoration project. The previous parts to this series are below the Show More tab, just below this video. So you'll see the video's description and a Show More tab. If you click on that, you'll see, you know, part 1, part 2, part 3, part 4, all the way up to this ending, I guess you could say, ending portion to this CR-88 radio receiver restoration series, at least for this particular radio receiver. So we will be moving on in the future to other radio receivers that will be compared to this one. They will all be challenging one another. Should be a lot of fun here in the near future. So I hope you enjoyed the restoration of this radio receiver. Thanks for stopping by the lab today. Hope you enjoyed this video. If you are enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. There'll be a lot of repairs and restorations and teardowns and all of that great stuff on this channel. So if you haven't subscribed, now would be a good time to do that, and definitely tap that bell symbol. That way you'll be notified as soon as I post a brand new video. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.